Okay, so let's start. So once again, thank you everyone for attending this session. Today we're going to try to answer, or at least to give some part of the answer, whether we can operate and use an edge computing infrastructure with OpenStack. So before starting, who are we? So my name is Adrien Lebre. I am an associate professor at IMT Atlantique. This is an engineering French school and a research institute in France. I am the PI of the FEMDC SIG, and also the PI of the Discovery Initiative, which is an academic project that tries to solve the question of delivering a resource management system for the fog and the edge infrastructures.
Good morning, everyone. I am Dimitri, a French researcher at INRIA, working with Adrien on the Discovery project. And my work deals more with the deployment and reconfiguration of cloud applications on edge infrastructure. So as such, I'm a contributor to the FEMDC SIG, and also to INOS, which is a framework to evaluate the performance of OpenStack given different topologies like edge, for instance.
Hello, everyone. Good morning. My name is Fatah Ouhib. I'm a researcher at Ericsson, stationed in Montreal, Canada. My research focuses mainly on scalable and distributed cloud platforms, and then trying to understand how to make existing cloud platform perform in a large-scale distributed setting.
Thank you, guys. So before starting into the session, what's wrong? Let me check. Here we go. OK, let's do it like that. Sorry for that.
You lost the focus, maybe.
Right. So wait.
Yeah, maybe you should click there.
Wait. OK, so sorry for that. So before starting into the real content, I would like to give you a short overview of what is the FEMDC SIG and what is behind these few letters. So the FEMDC SIG actually is a working group that has been proposed in 2016 in the OpenStack community in order to try to make progress regarding this question of the edge computing. So at that time, edge was not so buzzy. Some people were talking about fog computing, especially due to the proposal of Cisco in 2013. Some people talk about edge. And actually, if you really try to give to that infrastructures from high level, the common point is that all those infrastructure can be considered as a distributed clouds, massively distributed clouds. So what does it mean? Concretely, the infrastructure we are considering in this working group is the following one. We are considering actually a significant number of micro or nano data centers which are interconnected through wide area network wire link. So what does it mean? It means that you will face high latency, you will face intermittent network, and possibly some network partitioning issue. Our work and our studies are limited to that scope. So maybe you heard a lot of presentation during this week where people talk also about IoT devices and all that stuff. In this working group, we are already trying to solve the question of massively distributed clouds. So we are not going to deal with all the challenges that are related to what we call the extreme edge frontier, such as putting some micro DC in an aircraft or in a train and all that stuff. So if you want a number of such infrastructures, yesterday there were a really nice talk given by someone from China Mobile, where you can find actually the infrastructures envisioned for 2020. And they give a lot of numbers regarding the size of the micro DC, the size of the size of the number of micro DCs they will have, so their infrastructures, the latency. I mean, they give a lot of order of magnitude of all those numbers. So I already invite you to give a look if you're interested by that. So what we are doing in the FEMDC basically can be classified in two category. The first one are studies related to the OpenStack performance. So basically, we evaluate the scalability of OpenStack. We evaluate the impact of the wide area network latencies on the OpenStack. We evaluate also some alternatives. For example, instead of using RabbitMQ, you would like to use a more switched communication bus. So this has been presented. 2 days ago. Just after this talk, we are going to present some DB alternatives, in particular using CockroachDB, which is a new SQL database. And the second category of the work we are doing are related to the use case and the requirements specifications. And this morning, the talk we are going to deal with is the classification of such requirements and the impact those requirements will have on the code base of the vanilla OpenStack. So let's start. I don't know how many people attend presentation this week, but I guess that most of you are aware that the ultimate grail we are looking for is a resource management that will enable operators and new players to orchestrate and edge infrastructures. So if you look to the GAFA, to the big player of cloud markets, Akamai and Amazon are proposing an edge solution. So for Akamai, it's called Akamai Cloudlet, and for Amazon, this is the Lambda Edge. But if you look into details, actually, the only stuff you can do are related to the web applications. So what does it mean? It means that DevOps can only deploy specific web functions at the edge. And what we would like to offer to our DevOps is the possibility actually to deploy VMs, containers, bare metal at the edge. So those solutions exist, but we are not considering them in this quant study. The system we are going to consider is on one side OpenStack, and on the other side, all the different systems that are based on what we call a federated approach. So the main idea is that you have an orchestrator at the top level that will be in charge of orchestrating all the subclouds. So among the different solutions, we can cite Tricycle. So Tricycle before the splitting. So I guess that maybe some of you are familiar with Tricycle nowadays that enable to do network interconnection between clouds. But at the beginning, the goal of Tricycle was really to orchestrate and use such a massively distributed clouds. Etsy also proposed an architecture, but as far as we know, there is no implementation. ONAP is something which is also famous, especially during this week. But ONAP enable actually to deploy VNF at the edge. And you have also academic proposals such as Fogbo. So Fogbo is a presentation that has been given during the Barcelona Summit. It is a middleware that is developed by Brazilian academics and that enable to actually orchestrate several clouds. So once again, if you look to those systems, they are good, but unfortunately, they are only focused on the DevOps perspectives. So what does it mean? It means that, for example, if you look to ONAP, you can deploy VM across several clouds, but from the administrator point of view, the operation you can do are rather limited. So what does it mean? It means that all the solutions are not really suited right now. Once again, okay, so what is the target we are looking for in this SIG? Our target is a resource management system that will actually enable admin and DevOps to do the same operation that made the success of the cloud computing platforms. The specific of our working group is that we do not want to reinvent the wheel. We would like to mitigate the development efforts. Why? Because actually we believe that it's a nonsense, technically speaking, to re-implement a system as big as the OpenStack one. So our idea is to investigate what are the components we can reuse and how we can reuse these components to satisfy our challenges. So how we can move forward? The first things we should do is to identify those requirements from the admin and the DevOps perspectives, to study whether the current components of OpenStack can satisfy those requirements, and finally, to investigate whether there are better design choices. And actually, this is rather good because this is the agenda of this talk.
So indeed, before investigating if OpenStack can be used to operate and administer an edge infrastructure, we must first identify the requirements for both admins and DevOps regarding such infrastructure. So with the use case presented earlier by Adrien regarding the edge infrastructure, we have listed the features, those features from the admin and DevOps viewpoints. As we brainstorm these features, actually, we observe that they can be classified into 5 levels, which are depicted on the table of this slide. They are sorted from the easiest aspect to the most complex ones. So the first one is regarding the management and the use of a single site, while the second level is more complex since it induces the operations that involve many sites, actually. Regarding the third level, since network failure is the norm rather than the exception in such infrastructure, we consider the notion of robustness with regards to split brains. The level 4 and 5 are the most complex ones. Actually, the fourth one involves the implication of multiple infrastructure managers inside infrastructure, and the last one considers the fact that you can have multiple operators that own different sites in the infrastructure. So let's start with the first level, which contains the actions that admins and DevOps expect to find regarding a single site. So for example, administrators expect to manage sites, so install, remove, and update OpenStack services in a site, as well as managing users, their quotas, and elements like flavors. On the other hand, DevOps have other expectations. They expect to provision resources on demand regarding computing, storage, and network resources for a single site. However, they both have similar expectations. One of them is to collect metric for supervision, but it could be also regarding security, since, for instance, edge sites can be physically attacked. So, since edge sites can be unmanned, it is important here that all those operations are able to be triggered remotely. This level is actually straightforward regarding the edge viewpoint, since most actions are already provided in OpenStack. So another way to say that is that each site can be considered as an independent OpenStack instance. The second level is more complex, because it considers actions that involve multiple sites. Such operations includes operations like managing and provisioning multiple resources on multiple sites, like in the figure on sites 2, 3, and 4, but also gathering and analyzing information from multiple sites at the same time, and collaborative mechanisms regarding security, for instance, like secret key sharing or cross-site network encryption. Here we identified two kinds of collaboration, intra-service and inter-service. Intra-service are the kind of operations that involve the same service at two different sites. For instance, operations like configuring a user with different rules for the site 2 and site 3, or listing VMs on site 2 and site 3, which is respectively keystone-to-keystone collaboration and Nova-to-Nova collaboration. For the inter-service operations, it considers different services at different sites. One example is to boot a VM on site 2 using an image which is located on site 3. So this is Nova-to-Glance collaboration here. This notion will be discussed later in our analyses. So we have different ways to request collaboration. So because of that, we set two sublevels. You can actually request actions explicitly or implicitly. In the explicit manner, admins and DevOps has to explicitly target the sites they want to be involved in the operation. For example, here I have written a dummy command line which actually lists the servers for site 2 and site 3. In an implicit manner, you expect autonomous actions. For example, I want to boot a VM on the appropriate site of my infrastructure regarding some rules like energy consumption or locality awareness. So these are policies, as well as some constraints like hardware requirements, for instance. So in such case, the resource manager is in charge of taking the right decision regarding the user desiderata and the state of the infrastructure. And it can enable things like relocating workloads from one site to another site automatically. So the third level considers the previous features, but adding the ability to deal with split brains. In this figure, we can see that the site 1 has been isolated from the other site due to network partitioning because of a network failure just before site 1. So here we have different considerations regarding the partitions. You need the L1 features for the partitions that hold a single site, which is the case for site 1. And you need L1 and L2 features for partitions that hold multiple sites. This is regarding the first point, this is because L1, of course, impacts only a single site. We have here identified two sublevels as well. The level 3.1 is considering the fact that deployed applications should still run despite a split brain. And the second sublevel is regarding the fact that administrators and DevOps should be able to manage and provision resources even if there is a split brain regarding the infrastructure. The fourth level is more about is using the same adds the fact that you can have multiple infrastructure managers environments in your infrastructure from L3. So in these points here, it considers first that you can have multiple Vim versions. So you want, for example, collaboration between OpenStack Mitaka with OpenStack Queens. And it's also considered the fact that you can have multiple Vim technologies, like collaboration between OpenStack and Kubernetes, which have different concepts. This requires the ability to discover sites capacity in order to provide such collaboration. In the last level, we consider the same features as L4, but actually we add the fact that sites of our infrastructure can be owned by different operators. This is similar to what has been done in 3GPP for mobile telecommunications with the roaming technique. So regarding the administration, there is no expectation here because an operator would not let another operator to administer his own infrastructure. But from the DevOps viewpoint, you want to be able you want the operators to share their resources for the DevOps to be able to use it. Another consideration is that you want to collect the relevant metrics for billing, but you don't want to share all your information because operators want some metrics to be hidden from other operators. Okay. So here is the summary table of this study. For the following of the presentation, just remind that we have 5 levels. The first one is requirements regarding a single site. The second one is regarding multiple sites. The third one had the fact that you can have a split brain. Then the fourth one is about multiple cloud environment, and the fifth one is about multiple operators. So now the question is, does OpenStack is able to fulfill all of these requirements?
So let's start to dive into the OpenStack deployment scenario and check whether we can satisfy those requirements. So the first deployment scenario, which is well-known and that has been investigated by a few companies and few academics, is what we call the centralized management deployment. So the main idea is that you keep the control plane in a centralized data centers, let's say the master clouds, and then you will have only remote compute nodes at the edge. So this scenario has been strongly investigated, in particular by telcos, for the VCPE use case. So you can see a couple of presentations that deal with this deployment scenario, so in Barcelona, in Boston, or even once again 2 days ago here at Vancouver. So I'm not going to dive into details about all those technical aspects, but basically, as I said, you have all the core services of OpenStack that are deployed on the masters, and then you only have compute node on the remote nodes. So by such a way, actually what you have is that you have a standard OpenStack, but with a wide area network connectivity between all the components. So what does it mean? It means that L1 and L2 requirements are satisfied in a straightforward manner. As I told you, actually what you have is that you have a big cloud, which is geographically distributed. L3.1, which was related to the application's robustness, can be satisfied partially. Actually, the VM that has been deployed on the compute node, if the compute node is disconnected from the centralized master, VMs can still satisfy, I don't know, web server requests and whatever. But for example, you will not be able to restart the VM if you want to scale your applications. So that's why we said could be satisfied. Regarding the L3.2, which was the issue related to the network partitioning, there is no way. Actually, when you have everything in a centralized master, you design a beautiful SPOF, single point of failure. So which means that actually the pro of this approach is that you have a single pane of glass for the admin and DevOps, but the cons is that you have a single point of failure. The second deployment we considered in this study is the region 1. So here the idea is that you have multiple independent OpenStack that are each belonging to one region, and you have one keystone that will actually federate all those regions. So the same, I'm not going to dive into details about how you can do that with keystones. There are several approaches. If you are interested by that, please stay in the room and you will see the next talk. But basically here, what is important for this talk is to try to evaluate this deployment scenario with respect to the aforementioned requirements. So for the L1, each seat is completely independent, so which means that you can perform any operations. For the L2, there is no way. So this is similar as the cells. There is right now no mechanism that enables to do relocation between regions or to be able to start a VM from region A using the VMA from region B. Or you can do that, but in that case, it means that you have to put glance in the centralized master. So even if you turn the button, you cannot satisfy those requirements. Regarding the L3, which was related to the network partitioning, the challenge is related to keystone, because as I told you, keystone can be a SPOF. For L4.1, this has to be confirmed, but it should be OK. So L4.1 was related to the different version of OpenStack. You have one region with Mitaka, one region with Queen, and will it be possible to do that? So this should be cool. This should be OK, considering that the API is the common one. For L4.2, this is not possible, obviously. You cannot have a one region with OpenStack and another region with Kubernetes and put that in the same keystone system. And for L5, the same. There is nothing right now that enables to do bidding between different regions that are belonging to different operators. So basically, here, if I try to summarize, the centralized approach does not satisfy all the network partitioning issue, and the region does not provide the collaborative mechanisms. So once again, if you remind at the beginning, we introduced two kinds of collaboration, inter-service collaboration and intra-service collaborations. That is the collaborations we would like to satisfy. And in the following of the talks, we are going to see how we can do that by investigating different design approaches.
OK, so I hope by now we've managed to convince you that OpenStack, as it stands today, is not ready to fulfill all the requirements that we set out for an edge infrastructure. So then the question is, how do we move forward? Then we can start with how everyone else is doing it. So the way most people are trying to solve the edge problem today is by following this what we call the top-down approach, where you have a full stack Vim or full OpenStack deployment running on all your edge sites, but then you put on top a simple infrastructure manager that talks to all these Vims through their northbound APIs, and it also exposes its own northbound API to admins or the DevOps, right? And this approach is very simple, and this is what everyone uses, right? And then there is a reason why everyone does this, and it's because it's often very simple to get started with, right? I mean, if the main problem that you're faced with is trying to get a single view of your all virtual infrastructures that are deployed in all your regions, then you would come up with a solution. And this is what, for example, Kingbird does, right? Since you're trying to developing your solution independently from the Vim code, what this means is that you can develop your solutions faster, your solutions would be simpler, they could be tested faster, and we know since you don't need to change the core OpenStack, they could be adopted easier, right? But there are some drawbacks with this approach. The first one is that there is a lot of duplication, right? There is a duplication of Vim functions, right? Because if the infrastructure manager on the top is expected to provide, like image management services, like Glance, then, Glance is already there in the Vim. So you are duplicating an image management function on the top. And then you will also need to duplicate state between different sites and the two different layers. It could be data, etc. And in addition to this, there's actually an even more serious problem. And this problem is that you won't be able to fulfill all the requirements, specifically the L2 requirements that require two sites to collaborate with each other. A very simple example is that, okay, if you decide that you want to migrate a virtual machine from one OpenStack site to another, that's not possible, right? You can't simply do it because OpenStack today does not have any mechanism that allows you to move a VM from one site to another. So the way to solve this is to actually follow a bottom-up approach, where you actually bake in collaborative mechanisms within the sites, within the VMs, or within the OpenStack itself, right? So if you want to migrate a VM from one site to another, basically what you should be able to do is that there should be a site, the two sites where a VM needs to be migrated to and from, they need to collaborate with each other, and then implement the VM migration. And since all of these sites also have their own northbound API, they still would be able to be used as an entry point to the system. Right? Now, this is actually a really elegant solution, but unfortunately, today we only have academic proposals out there, so there's no practical solution. And then there is a reason for that. Now, as you can imagine, there is a minimal duplication of effort because you don't have, an additional layer where functionalities are duplicated. And since you're free to change the code of the Vim, there is a potential for you to be able to implement this, all the requirements, right? So this should be the way to move forward to get a solution for an edge infrastructure. But unfortunately, it's not easy. And the difficulty actually comes from different dimensions. So the first one is that now in this setting, you're dealing with a distributed system that needs to do some form of peer-to-peer communication. You need to keep track of data consistency across different sites, and then you have the one in there that has latency and then packet loss. And these are classic computer science problems that are generally hard to solve, right? And even if you can now solve these problems, then actually getting them into OpenStack is also a challenge. For the top-down approach, you only need to understand OpenStack APIs. And once you understand OpenStack APIs, you can simply have your solution working. But then for this thing to work, you actually have to be an expert in the different components of OpenStack and how they work and how the code works, and then to make sure that whatever you put into OpenStack doesn't actually break OpenStack, right? And then, there are also some non-technical challenges, like, L4 requirements, L5 requirements. How do you talk from Kubernetes to OpenStack or from between OpenStack and Kubernetes? What's the way to do that? Or, there is this age-old problem of, different operators collaborating to build a service. What data do you expose, and how do you make sure that there is a a fair way of exposing data and then providing a fair service to your users. These are the L2, L4 challenges that are not easy to solve. And then, of course, at the end, even convincing the OpenStack community to change something major in the code is going to be hard. If you go and then say, OK, we want to change the core of OpenStack Nova, the community is going to say, no, thank you, go away. We don't want our system to change, because this is something that runs today, and then making a major change is going to be very difficult. So what's the solution here? Well, the solution has to be a hybrid approach, right? And since top-down can't fulfill all requirements and bottom-up is hard, the only way to move forward would be that for those functions that cannot be implemented through the top-down approach, there is no other way. You have to actually implement native collaborative mechanisms inside OpenStack. They have to be baked in. There's no other way around it. But then, for all other requirements, there's always an option of either putting them, inside OpenStack and implementing them through, peer-to-peer type collaboration, or trying to implement it on the top and top-down approach, right? OK. So to summarize, we started by saying that, OK, the need for, an edge cloud platform is here, right? The infrastructure is already there. The applications are almost there, right? So there is the need, and then we have to be ready for it. But then the question is, what software do we use for that? We identified that, for an edge infrastructure, there are a number of requirements. We categorize these requirements into these 5 different levels. And then we showed that, OpenStack, as it stands today, would not be able to fulfill those requirements. So we investigated different alternative methods for that. We looked at top-down, bottom-up. And then we conclude from there that you actually need a hybrid approach that actually takes both top-down and bottom-up functions, our approach into it, right? So before we wrap up, maybe I'd like to point out some important takeaway messages here. So maybe the first thing is that for Edge to be a success, right, it's very important that we have collaborative mechanisms put in OpenStack. So without these collaborative mechanisms, I don't think Edge would be a success. So it is kind of important. So we have to figure out what are these mechanisms and how to implement them, but it's a given that OpenStack mechanisms have to be in there. The collaborative mechanisms have to be there. And then, how to implement these collaborative mechanisms? Some of them are extensions to existing services, but some require, implementing new services from scratch. So, as a community, we need to identify what are these services, that need to be implemented, that need to be extended. And so, as a step forward, I think that what the community needs to do is first, propose an architecture that mitigates the development efforts while addressing the identified requirements. Right, that's the first step. And then once we have an architecture in place, then we should identify, the most important functions and, start coding. Thank you.
Thanks. Questions?
I'm wordless, actually. 50% of the problem is recognizing that we can't do it. I'm happy to hear that we are not able to do with what we have currently in OpenStack. Top down, bottom up, middle down. That's the first sign that we are halfway through now. The other half of the problem now lies from your conclusion. You have said that hybrid approach is the best way. Now, hybrid approach and collaboration. Now, collaboration within, collaboration outside us. Because if edge computing needs to take off, just putting use cases and, oh, I can do it myself is not the correct approach. So we have to deal with the use cases that are brought from ONAP, Akreno. We have to look at what the other industry players are saying. So in that respect, the first attempt to solve this should be to try build a blueprint. And I would request that since you are the expert, you are really brought into inside all the approaches of federation, delegation that are required from top down to the bottom up, of being able to do at the Vim level migration and moving the services and all. So I would like you three, being the experts, try help us in build the blueprints for hybrid approach. Have some, I don't know, you have for HC, you have got different inputs. So if you can help us in build the blueprint, I would appreciate. We have a session in the evening for Edge, bird of feather, also in the morning today. And if you can give your slides and share with others, we would be happy to move the ball rolling for the 50% which is remaining now. So fantastic. If you want to say something on the blueprints, you do have already, or you have attempted, let us know.
Thanks. Thanks for the comment. And by the way, there will be, the work will be presented from an academic perspective in the Hot Edge conference in July. So which means that you have an academic paper which presents all this stuff in details. And thanks for your comment. Any other questions?
Yes, thank you very much. Fantastic work.
Thanks.
Just, it may be naive, but just looking at what you shared, it's very compute-centric, image-centric. Have you considered the impact on networking or storage as part of the analysis?
Who'll start? You want? So actually, as Prakash said at the beginning, I mean, you have too many use cases. You have plenty of use cases. During the 2 first years of the working group, we tried to identify all those use cases. I don't know whether Paul-André is there, so the other co-chair of the FMDC SIG, but we tried to identify all those use cases. And at the end, we saw that it was impossible for us to be able to discuss in an agnostic manner with all those use cases. So what we did, we said that, OK, let's try to propose the classifications where actually you can put all those requirements. And for example, when you talk about network, if you want to do a cross-network tunneling between 2 sites, those requirements will be attached to what we call the L2, which is the collaboration between services across sites. And then if you want to dive into details, we identify 2 levels of collaboration, which has, for example, if you look at Neutron on SDN, when one SDN controller wants to collaborate with another SDN controller, we will call that intra-service collaboration, because this is the same service. And then if you want, for example, to provision a VM on one side and a VM on the other side, and you need to make a tunnel between those VMs, in that case, you will have inter-service and intra-service, because Nova will have to discuss with the remote neutron, and at the same time, the 2 neutrons should interact each other in order to be able to provide the requested network. Right. So once again, the classification that we present today is agnostic in the sense that this will enable us to move forward without diving into the nightmare of trying to solve every use cases. Right. So that's really the goal of the stuff. So I hope we can add all requirements, such as the one you can consider storage or network, inside one of this level. And if not, we will be happy to discuss that offline.
Understood. Thank you.
Thanks.
He goes first.
Okay,
he was there at the mic before.
Aloha. Thank you for the good information. The edge use cases that are close to deployment right now, like the 5G applications, force all the logic of the distribution into the application. Okay. You're imagining kind of a meta cloud, whatever words you want to describe it, that would provide OpenStack-like services across a large geo-distributed environment. I'm more interested in imagining what the application environment would be, because I think that if we can imagine what the application environment looks like so that a application developer who doesn't like, they're not dealing with neutron calls, they're not dealing with Nova calls. What kind of environment are they working in so that their application can be appropriately massively distributed without requiring them to actually understand this underlying cloud fabric? I think that would be very interesting work, and it might drive where some of this goes. I think it might be more interesting than just saying OpenStack calls everywhere.
So I think too. I think it's very relevant. So thanks for your comment. I definitely agree with you. The point is that it's like actually an operating system versus the application at the top. So developers think about the applications on the top, but they do not want to consider the operating system. But someone has to provide the operating system. And in this work, we try to provide this operating system. So I completely agree that there are a lot of challenges related to all those aspects you mentioned. Definitely. I think that people at ONA, for example, are already make good job trying to understand how you can do that. But at the end, this upper layer should be put on top of something at the low level. And the goal of the FMDC is to try to advance by leveraging OpenStack to provide such operating system for the edge infrastructure. So your comment is definitely valuable, I think, and I hope that both work are complementary.
Hi. I will try to help you just a little bit move the needle instead of churning the whole ocean. One is there is a mix match. Have you seen it already?
Yeah.
Okay.
Yeah,
so for the intra service. So that is one, which will help you in your scenarios. The other one is I'm working on integration options between OpenStack and Kubernetes. We already have keystone authentication and authorization working across. I would be interested to know what other scenarios that you need working so we can organize the work in the Kubernetes communities or in the OpenStack communities, wherever it is needed.
So definitely, and especially because actually there is a new group in the Kubernetes communities related to the fog and the edge stuff since a few weeks.
So you know how to find us, right? SIG Kubernetes?
Yeah,
okay.
exactly.
Okay, thank you.
Thanks for your comment. So I think we are run out of time now. So thank you for the questions, and thanks for attending the session.
Thanks.
Thank you.